Well, hello, I'm Amy Guerin, the Director of Brand and Digital Strategy with AOCS. Thank you so much for joining us today. Today, we're here to hear from presenters at the 2021 ISSFAL Congress. And we have Guy, Ben-Zvi, and Elisa Dunkel, and they can correct me if I mispronounced anything, from Omega-3 Galilee. And as I mentioned, they did have a presentation at the ISSFAL Congress, so we're very happy to have them join us to expound upon that research. For my attendees, we will do a Q&A at the end of this webinar, so any questions you have, you can write those into the question box to be addressed at the end. And all attendees, you will receive a link to a recording tomorrow, as well as receive your certificate of attendance. So look for that in your email tomorrow. And so with that, thank you everyone for joining, and thank you so much for our presenters for being here. And I will turn it over to you.
Okay, so thank you very much, Amy, and hello, good evening or good morning to all the participants. My name is Guy. I'm from a small company in Israel called Omega-3 Galilee. We specialize in distribution and research of omega-3 for human consumption, mainly in capsules, and this is what we do 24/7 and specialize in. And today I'd like to talk to you about one of the biggest problems in the omega-3 market as we identified, and this is the oxidation problem. And I want to propose ways to measure it, control, and mitigate it. If there are any questions, please write them in the chat, and I'm sure to stay here until the last question is answered. So let's begin. So first, as an introduction, a background of this topic. So everybody knows that omega-3 PUFA are structurally and functionally essential, and their deficiency is detrimental to human health. But the major drawback of omega-3 is their high susceptibility to oxidation, and this affects their quality and their safety. Exposure of omega-3 to environmental factors like high temperature and high humidity and some other factors like ion metals during their shelf life affects their oxidation rate. So it's not a static thing, it's a very dynamic thing. A significant percentage of commercially available omega-3 products on the shelves on the markets in various markets all over the world have an unacceptable level of oxidation before their expiry date. Typically, the expiry time for omega-3 products for human consumption is 3 years from manufacture, but actually they expire before that, or they oxidate before that. We also found that liquid oil formulations usually contain flavors, typically aldehydes, to overcome the fishy taste, and this by itself is a problem because it biases the secondary oxidation measurements that do not allow proper oxidation quality control during the whole shelf life. And in this presentation, I will present these 3 different topics of this problem and try to propose how to solve it. So our methodology is very simple. We measure the oxidation status of many tens of commercially available omega-3 fish oils on the market in various forms, plant, fish, algae, and also liquids. We studied the oxidation mechanism and defined suitable storage and handling conditions to ensure acceptable quality products on the shelves. We mainly put our efforts on constant humidity at differing temperatures and constant temperature at differing humidities. This is a picture or 2 pictures that show the typical setups that we have. We have incubators with constant temperatures or constant humidities with different salt formulations that simply maintain a constant humidity. So we have several of these setups. And here you can see this is very bad omega-3 after a really long time. So you can see that the fish oil actually became dark, but this is just to show you an extreme case. Normally, we don't need to go so high with the oxidation as to get to color change. So the results of our research, our first study that began about 5 years ago or 4 years ago, just check the products on the market. We are in Israel, so we simply collect products on the market every year. We have maybe 15 brands in Israel. And we show here results of 50 products selected randomly, but we know we typically take fresh batches that are relatively young, so we don't bias it. And these are the results that about 30%, 15 out of 50 products exceeded the upper limit of total oxidation, TOTOX of 26. TOTOX 26, if someone doesn't know about it, this is a compound value of peroxide and para-anhydride. And this is the value, the maximum value allowed or tolerance allowed by GOED, which we are members of, so we commit to selling products that never reach TOTOX 26. And you can see that some of the products really have very high TOTOX, some of the products have close to the limit. So the situation is far away from safe. Then we went and studied on our own product with our own batches of omega-3 during about 3 years, the different oxidation levels at different temperatures at constant humidity. These tests are at 75% relative humidity, again maintained in a desiccator with salt sodium chloride. So the official capsules were sealed in PET containers, like the product is sold on the market, like I showed on the previous picture. So the capsules are not open. If they were simply open, all this thing would happen in a few weeks and not in months. And we store them at 45, 25, and 7 degrees C. At 45 degrees Celsius, you can see that about less than a month, we reached the TOTOX 26 value. At 25 degrees, it's about 6 months, and then it goes up very rapidly. But at 7 degrees, we reached 3 years, and actually we extended this test, and it's ongoing. And after much more than 3 years, you can still have it at not past the TOTOX 26, but it does oxidize at 75 RH. So you see it's slowly going up. Maybe we reach the TOTOX of 20. What we can also see here is something very typical. Anybody who studied PUFA oxidation, you can see a plateau at the beginning when there is no oxidation. And at every temperature, at the higher the temperature is, the shorter is the plateau, but the plateau is similar in shape at all temperatures. And this is the time that the antioxidant that's in the oil is protecting it. But this is limited. As we know, we cannot add endless amounts of antioxidants because it becomes a pro-oxidant. So this is limited. So this is the way temperature affects it at room conditions of relative humidity. What about the effect of humidity at constant temperature? Because as we saw, it still oxidizes at 7 degrees C. So here again, we have 3 tests. These are separate experiments in sealed containers at 7 degrees C and at 100% RH, at 70% RH, at 20% RH. And we can again see a plateau, but quite surprisingly, at 100% relative humidity, suddenly at around 24 or 23 months, it starts jumping up and it oxidizes much above the limit. So this reaction happens also at low temperature, but at high humidity. If we go to 70% RH, which is similar to the 75% that we saw in the previous experiment, we can see that we can get maybe 30 to 32 months, but not 36 months, not at 3 years. But if we go down to 20% relative humidity, which may be a challenge to do, but still this is what the science shows us, you can really maintain a plateau. And if we extrapolate this into the future, maybe it's 4, maybe 5 years. We don't know when this inflection point is going to happen. And definitely we will be more than the 3 years that the manufacturers of the fish oil state. Okay, so this is the effect of humidity. What about the liquid fish oils? The liquid fish oils are more complex to study. We collected, or we didn't collect. Here we actually created our own fish oil formulations. We took fresh fish oil without any flavorant, and we added typical flavorants that are used in the industry from a company called Frutarom. And we added, the way this experiment worked, we added this to fresh fish oil, tested it immediately after adding the flavorant to see the effect immediately of the flavorant itself, and then after a week, and after this week, during this week, the bottles were sealed, so there was no exchange of air, just the air that was introduced while opening it. And this is simulating the situation when you have at home a bottle of fish oil, you open it once, you expose it to air and you close it, or you pour a little bit outside and you have this small headspace that's now oxidizing the fish oil. We used fresh fish oil and MCT oil as control. And what we can see, if you look at any one of these experiments, the blue bars are before the flavor was added. So we have two experiments here. In experiment number 1, all the blue bars are approximately at the same height. This is about 5 totox of 5, or maybe a little bit more than 5, maybe 6. Just after adding the flavor, it jumps up maybe to 15. And after a week, depending on the type of flavor we added, it goes additionally up. So what we can say really based on this experiment is that we can't say anything, because we don't know what is the level of aldehydes created from oxidation of the fish oil compared to the level of aldehydes created just by the addition of the flavor, at least at the initial stage of after adding, because it actually multiplies or triples or quadruples the level of totox. We did another experiment. So this is a different batch of fish oil when we took MCT and added the flavor to MCT, and we know that MCT hardly oxidizes at all. Medium chain triglycerides is 100% saturated fat, and we can see the same effect. We're not sure why we had such a large effect with MCT with lemon, but we definitely know that this is the result of adding the flavor and not the MCT by itself oxidizing. So we know that it's affecting, and unfortunately, we can't tell what exactly is going on. Maybe the flavor, these aldehydes, accelerate oxidation, but theoretically we may get such level of aldehydes that we get tertiary oxidation products, and some of them may be, for example, ketones, which would act as antioxidants. So it's very, very complicated, and it's practically impossible to predict and to say what is the level of oxidation of the fish oil itself in these conditions. Then we went to the textbooks and wanted to duplicate graphs seen in the textbook. So we actually did it. This is a very long experiment. We took bottles of fish oil and we exposed them to oxygen for just a few minutes and then shut them down with nitrogen and just let them stay. And every few months or every month or two, we checked another bottle, and we got the classic graph. Here you can see the green line is the peroxide value that goes up very fast. You see it starts, all of them. It's a very good fish oil with very low initial oxidation value. It goes up very fast and then it starts dropping. So just checking peroxide tells you nothing. Actually, after 20 months, it went below the initial value. What went up was the aldehydes. So you could say, let's check aldehydes, but it's also not incorrect, because at the beginning, the aldehydes are very low. So if we look at the graph, which gives us the real picture, this is this blue line, which is the totox, which captures both the initial rise in peroxide and then the secondary products of the para-anhydride of the aldehydes. So this really showed us that the mechanism works like in the textbook. And this also explains why you can't actually measure oxidation in a product that contains artificially added aldehydes, like flavor materials. This is very unfortunate, because we all want to add flavors to our products, or many of us want to do it, but we actually obscure a problem. And we don't know if the aldehydes that are in there are just from the flavor, which are acceptable, or maybe it's MDA, or maybe acrolein, or one of those more toxic aldehydes. So what do we actually think is going on? So this is our discussion. So we know that omega-3 products from all sources, I didn't specify, but we checked all the sources, so fish oil, algae, plant, and liquid oils. So these products with oxidation above Totox 26 are available on the market, putting customers at risk of consuming rancid products. Most omega-3 products under Totox 26 at the point of purchase will pass the limit before the official expiry date if stored at ambient conditions, 25 degrees Celsius, 75% RH, which is typical, at least in Israel. Winter, summer, this is what you have in your kitchen. So this is also very disturbing. I'm not showing the data here, but if anybody's interested, we really dug very deep and we saw that this is actually happening to products that we buy off the shelf, keep them in these conditions for until their expiry date, and we find that they really do pass the Totox 26 before their expiry date. We found that the environmental conditions of storage as high temperature and humidity accelerate oxidation and reduce the shelf life even in sealed containers and before the expiry date. And this happens in plastic containers, polyethylene, PET, or in glass containers. It doesn't matter. Actually, we think that the biggest problem is the air that is entrapped when you pack the container with the capsules. And of course, also some humidity is entering through the seal and through the lid or through the plastic. So this is happening. We found that some liquid fish oil products contain aldehyde flavorants and suffer from uncontrolled quality during shelf life and possibly rapid oxidation after opening. As I showed, we didn't find a method how to check it. I asked with many GOED friends in GOED, and nobody could give us a method how to check, how to separate the different types of aldehydes. Refrigeration is a simple solution for eliminating excessive oxidation, ensuring at least 3 years of shelf life post-production. This is what my company does. We maintain a refrigerated shelf storage conditions all the way from the minute the capsules are manufactured and shipped to us. So what are the conclusions and recommendations? First, we think that you should monitor the stability and oxidation along the whole supply chain, including land storage and retail point of sale. It's not sufficient just to do it at the oil manufacturer or capsule manufacturer. And because we are GOED members and we are obliged to follow the GOED monograph, so we do it all the way to the point of purchase. We recommend to store omega-3 products in refrigeration along the full supply chain to ensure meeting Totox under 26 limit until the end of life. So these are the 2 simple recommendations. One note here about our company, Omega-3 Galilee, which I am the CEO of, and Alyssa here with me is a manager of R&D. So we are members of GOED, and as such, we are committed to GOED monograph all the way to the end user. We store our fish oil products refrigerated along the whole supply chain, excluding ground transportation of a few hours. Actually, we allow up to 3 weeks out of the refrigerator during the whole shelf life. When typically ground transportation is maybe 2 or 3 hours to the port and from the port to our warehouse. We test Totox post-production at the entry to our refrigerated warehouse, post-packaging, and every 6 months, hence until the end of life of every batch. And if anybody is interested in the references to our work, and if anybody is interested in much more work that we have, then you are welcome to contact us. And thank you very much. And I would be glad to take any questions. Alyssa, if there are any questions.
Thank you, Guy. I'm biased, but it was a great talk.
Thank you.
If anyone have questions, we can take them from the question box. You can write them down and I will read them. We have one question from Kelly. Will the presentation will be available to download? I understand that tomorrow you will get a recording points of the presentation, so you can also see tomorrow. If anyone have another questions, of course, we are here.
Maybe if you want to contact us, maybe I will show my. Do you see my screen, Alyssa, with the presentation?
No, just in your photo.
Now, do you see it?
Yes.
Okay, so if anybody's interested, these our emails are on the screen now, so you can take a shot of it and then send us an email. Or
And
if
I'll
you'll get
add those to the
we have more
recording.
questions.
I'll make sure that the email addresses are in that recording as well, in case you don't get them from this slide. But it looks like now we do have a couple questions.
Yes, we have a couple of questions. First, the use of Totox, do you think it's important only for fish oil or also for other oils in general? Thank you.
Wow. Thank you for this question. Actually, my company is studying now cooking oils. This is maybe interesting for the AOCS guys more than GOED guys, but we are checking cooking oils, and there is a huge problem when you fry with edible oils like olive oil or a grapeseed or sunflower or safflower oils, and they oxidize exactly the same mechanism of raise of peroxide, and then peroxide goes down and aldehydes go up, and it's very serious when it happens within minutes or 10 or 20 minutes when you fry at 150 degrees C in your kitchen. So it's a big topic, and we find that exactly the same tool, the same measurement equipment is very suitable for edible oils. And if somebody is interested, we can say what type of tool we are using, machine we're using to test this. So it's good for all the PUFA oils.
Okay, we have another question. Maybe it's relevant to go back to the presentation, because the question is how is the moisture impacting the Totox? So we show it, maybe
Okay.
present it again. And what is the MVTR for the bottle? I'm not familiar with this term. You know what is MTVR? MVTR.
Mean time before failure, maybe? I don't know. MTB is mean time before.
Maybe you will write us.
Can you see my screen now, Alyssa?
Yes.
Okay, so to the person who asked this, again, this is a graph of 3 samples of fish oil that started with a very low or relatively good Totox. The blue line started a Totox of about 10, which is very good for fish oil. The other 2 started at about 12 or 13. It's a little not as good. And they were all held at 7 degrees C. So this is refrigeration conditions, like your normal home refrigeration where you hold the milk and the vegetables. Okay, it's not in the freezer. And the blue line is a very humid condition, like really soaking wet in the refrigerator, 100% relative humidity. And you can see that after about 24 months, it starts shooting up, and then you lose it within 1 month, very, very rapidly. At 70% relative humidity, you can extend it maybe by 3 or 4 months up to 31, 32 months. But at 20% relative humidity, it's really a plateau. There is no degradation yet. Alyssa, did you see already on this sample any rise, or it's still static? Because you're the one who's measuring.
It's still static, and we have already, I think, 40 months already with no change
40
at
months.
all. Yes.
So almost 3.5 years. So maybe somewhere in the middle is good enough, but 20% relative humidity, it's a bit of a challenge, but it's doable. So we managed to do it. We managed to keep a big refrigerator at 20% RH.
Okay, great.
Okay, I hope this answered the question again.
I believe you will write us. We have another question about the Totox value. True, we missed the calculation from the presentation. What is TOTOX? How we calculate TOTOX?
Okay, we assume that these are GOED members and they should also know what TOTOX is, but TOTOX is 2 times the peroxide value plus 1 time the aldehyde value. And there were very long discussions many years ago within the GOED community, and they agreed on this TOTOX. And personally, because we did so many tests, I think TOTOX is a very good measure, and 26 is a good limit value, because approximately, if you're very experienced at tasting fish oils and oxidized oils, you will notice it at about 25, and you will start feeling really strong. You'll say this is oxidized at about 35. So the 26 give you maybe 10-15% limit or spare before your customer or the user will start saying this is rancid. At 45, you may throw up because of it. You really feel bad. You cannot consume oil with 45 TOTOX just like this in a spoon. You can maybe take it in a capsule because it hides the taste, but then you'll have a fishy burp and etc. So this is TOTOX. Sorry for not explaining it and taking it for granted that people know this value.
Okay, we have another question. Is there any one kind of fish oil, different species that oxidize quicker than others?
No, also a great question. We studied this also, and not only this was studied a lot. It doesn't depend on the source of the EPA and DHA. It only depends on the concentration of EPA and DHA. Basically, think about very highly unsaturated oil with a lot of unsaturated double bonds, which are all available to react with oxygen. So the higher your EPA DHA content, and this is worse, by the way, than omega-6, because in omega-6, in let's say arachidonic acid, you have less unsaturated, only 4 unsaturated double bonds. So the higher the EPA DHA content, the faster it will oxidize under the same conditions. This is why the highly concentrated fish oil with 85% oxidizes faster, and the 100% EPA, now there are products on the market like the drug, the Vasepa drug. This is 100%. I mean, I didn't test it because I couldn't get my hands on it, but it should oxidize very quickly. So if you buy 100% EPA or 100% DHA, it will oxidize much faster. And it doesn't depend if it came from anchovy, from sardine, from mackerel, from tuna. It depends on the concentration.
Great. We have a practical question. How practical is to keep the bottles in a refrigerator inside the stores and shops?
I can tell you what we do in Israel. We simply sign a contract with our distributors that they must keep it in refrigeration. So some of our customers have refrigerators for other products like probiotics and stuff like that. Some of them sometimes sell foods like milk products, cheeses. And but anyway, and if not, then we provide them with a refrigerator. Fish oil is so expensive relatively that the cost of a refrigerator is almost negligible. But it's a hassle, of course. It's a hassle, and it's a limitation, and it adds cost to your operation. It's actually more costly to hold the fish oil large quantities, big pallets with thousands of kilograms in refrigerated warehouses. This is expensive, but from our point of view, it's worth it. Okay,
we have another question. How will you test TOTOX? Is it per USP? I can answer it.
Answer it, Alyssa, please.
Yes, we test TOTOX by testing actually the primary oxidation values and the secondary, the peroxide value and the para-anhydride. We use the CDR Food Lab. It's the photometer which allow us to test quickly, much faster than the standard method. But all kits were standardized by the AOCS standard methods of peroxide value and para-anhydride value. So it's calibrated and validated, and we don't have any issue with that. The next question, What are the major health issues with high totox?
Wow, Alyssa, you studied this deeply. Maybe do you remember the list of diseases that are caused
Yes,
by?
yes, I can try. We have actually a big library of different kind of research and articles about this. It's a quite big list. The most remarkable study was that oxidized fish oil was given to pregnant rats, and there was a high rate of mortality of the newborns. It was actually very important study, but the disease are quite all the chronic disease, neurodegenerative disease, cardiovascular risk, etc., etc. And there are studies with animals. You cannot study on a human being such studies of toxicity, but there are some studies about pigs 15 years ago. Actually, it's nothing new here. It's a quite old study.
There's a new study on fish, right? On the yellow crabfish.
Yes, it's new from this year. Actually, we don't have the article yet. Okay.
Basically, I think the whole topic of PUFA, the toxic products of oxidized PUFA, began maybe 30 or 40 years ago when the food industry moved to vegetable oils, because you hardly have PUFA in animal oils. Even in milk, you have relatively low PUFA, and definitely in tallow and other animal fats. And it wasn't a problem, but when people changed to safflower and sunflower oils because they wanted to move away from saturated fats, you started getting more and more problems, and this was very well studied in the 80s and 90s. And then national standards, at least in Israel, but I believe also international standards, came out that you're limited by the level of peroxide and aldehydes and free fatty acids, and this is relevant only to vegetable oils. But the health risks and the health hazards were studied very well for those oils, and PUFA is PUFA. A double bond is a double bond. So the reaction products and the oxidation products are toxic if it comes from sunflower oil or from any other type of or olive oil, or if it comes from fish oil. So that's where it came from originally, and I think we should the regulators, the national regulators and international regulators should put down standards and regulations similar to edible vegetable oils.
It should be noted, I think. Yes, I think it should be noted that there are some countries around the world that they have this kind of regulations, like the the Codex, for example, which is international regulation on this issue. Yes, we have more questions. How long does the product stay under 26 totox, I believe, if open daily as in consumer use compared to static shelf life conditions?
Do you think she's talking about the capsules or the liquid oil?
I don't know, but I think you should answer both.
So you answer because you tested it.
Okay,
right?
So about
what happens when I take a bottle of 200 cc or 300 cc of liquid fish oil and I open it? What happens during the, let's say, the month that I use it? Maybe this was the question. So you tested it, so tell us.
Yes, I can say that if it's a liquid, my daughter wouldn't taste it. No, seriously, liquid fish oil is very sensitive to oxidation. Open fish oil in ambient conditions and exposed to air and oxygen have something like maybe 24 hours, 26 hours before it's totally oxidized beyond the 26, if not any kind of antioxidants are added. If some instructions are added, maybe we can prolong it for more. Daily use, we can hold something like a week without any antioxidants. With good antioxidant formulations, we can maybe 2 weeks, 3 weeks maximum, but not more. Compared to capsules. Capsules, actually, it's quite genius invention, because the gelatin is a great oxygen barrier, so we don't really have an issue with oxygen as primary initiation of the oxidation, but the moisture is the biggest problem, and the temperature. So if capsules we will open daily, but still keep refrigerated, we still have these 3 years from manufacturing, only if we keep, of course, low temperature and low humidity. I hope it answered the question. Okay, let's see more questions. How is moisture impact? We have this question. Okay. Fish oil is helpful for inflammation, heart issue, etc. But oxidation has more health issue than is benefit if not stored at 7 degrees and 25 RH. Okay, it's exactly what we are saying. Somebody agree with us, and it's great to hear this. Do you also help with other PUFAs and free fatty acids? I don't really understand the question. Do you also help with other PUFAs and free fatty acids? Maybe you can ask again and a little bit expand your question. We have some note here. Soft gels with fish oil are stable at 45 RH. It could be. We are testing right now actually 45 and 50 degrees percent RH, so maybe.
Yes.
Looks like. I don't see any further questions. Does oxidation also apply to plant-based oils?
Definitely. And it's even a more complicated situation, because when we see the plant formulations, and these are basically from chia or flax oil or maybe hemp oil, as far as we can understand the situation, the distillation process of these oils is not as good as fish oils. And the initial oxidation of these products, that at least the ones that we buy on the Israeli market, is worse than fish oils. And with algae, it's a pretty similar situation. Even when you buy it fresh, the taste is very strong, much stronger than a good fish oil. So a fish oil with Totox of 10, it's tasteless. You don't taste almost anything. But if you will take a plant or algae omega-3 oil, even at not very high concentrations, you feel a very strong taste or aftertaste. Usually it's sour, and the sourness tells you that the peroxide level is high, and we actually test it and find that it's high. So I think the technology for plant and algae, in at least the products that we tested, is not as good as for fish oils, which is a very well-established industry and knows how to do its job. Aliza, do you concur with this?
Yes,
What
I
do you
agree.
think?
I agree, because
you test all
the
these products, so.
yes, because fish oil distillation is so good, and they achieve such a good oxidation initial values that I don't think the plant oil industry is ready for it. Maybe if one day they will be, it could be a better product, but there are another issue of what is the plant oil? Is it the EPA and DHA, the eicosapentaenoic and docosapentaenoic acid, or it's the alpha-linoleic acid, and then it's such a different thing biologically, and so I don't know. It should be considerable. What is the source?
And there is another point. If you don't have a process like molecular distillation, which is what you do in fish oil, or very high efficiency distillation extraction methods, you get residues of contaminants that are not even contaminants. Think only even about chlorophyll. If the oil is a little bit greenish, it means you have chlorophyll and you have magnesium, and this accelerates oxidation. We know this very well from olive oil. Olive oil, which is a virgin olive oil, which is cold pressed, is much more prone to oxidation than distilled fish oil. And not fish oil, sorry, yeah, olive oil. So even with omega-9, which is only one double bond, you already see this effect. So if the plant and algae oils are not as well decontaminated and distilled and filtered, maybe it's also a reason why they deteriorate faster.
Well, we have the question,
More
maybe
questions?
we answer. Yes.
Okay.
Is fish oil that has been molecularly distillated more resistant to oxidations? I think we answer it. The answer is yes.
But today you cannot buy fish oil, which is, as far as I know, all the fish oil on the market was molecularly distilled and then re-esterified. So even if you buy a triglyceride, it's not the original oil like it came out from the fish. It was molecularly distilled and then reconstructed into either ethyl ester or a triglyceride. Okay, sorry. Yeah, go on.
What about algae?
So I answered it.
Yes.
We are yet to find a good algae oil that we would be happy to sell. Okay, there's also a problem, you know, with algae. You have a lot of DHA from algae and very little EPA, and EPA from algae is very, very expensive. So the formulations are high DHA, high EPA. This is a topic for a different lecture, but at least my company only wants to sell high EPA, relatively high EPA and less DHA in the formulation. I think they have a way to go still with the algae oil.
Bulk oil in big containers after opening and flushing with nitrogen. How long stable, even with addition of antioxidants?
We're not oil manufacturers, but we speak to our vendors, and they say that you can extend the life to many years, and you have to check it after 3 years, and then you can extend it by another year. So I think it's not limited, but you have to do it correctly. And it's not so simple to seal containers with nitrogen and really flush out all the oxygen. So basically, the more you draw down from your barrel, the more headspace you have, the more nitrogen you will have to flush inside. And if you'll get to a half-empty barrel, you'll have to use huge amounts of nitrogen. And therefore, you can find on the internet with the nitrogen vendors and people who do liquid nitrogen, you can find some equations that tell you how much nitrogen you'll have to flush with, but it can be a lot. So it's better to use the whole barrel at once, if you can, which typically what the capsule manufacturers would do. They would never open a barrel and leave it open. But if you have to, then, and if you do it correctly, I don't see any reason why you can't keep it for many years.
Another question about free fatty acids. What I meant was, what about free fatty acids on PUFAs rather than the oil? I believe it's a question about free fatty acid generally.
Okay, so you obviously have free fatty acids, a lot of free fatty acids in raw fish oil, but molecular distillation gets rid of it completely, and because it's re-esterified, so you don't have any free fatty acids. There are no free fatty acids in re-esterified fish oil or any other oil. The question is relevant for other oils which are not decomposed and then re-esterified, and free fatty acids are a problem. With vegetable oils, it's a big problem because, but also not only vegetable oils, any oil which was not treated by very high quality distillation, you may have free fatty acids. And they're a health problem if they're above a certain value, or if you consume them a lot, because they are very reactive and they react with things in your body. But with fish oil, it's not a problem at all. We check free fatty acids, and there are no free fatty acids or negligible trace amounts. Right, Alyssa? You check free fatty acids.
Yes, we check free fatty acids in different kind of oils. In distilled, molecularly distilled oils, we never seen high free fatty acids, higher than the regulation allows, it's for sure. Okay, we have another question. What form is in fresh fish oil prior molecular distillation?
What form? It's a tree
Yes,
before
form.
it's okay. What you get from the fish is a mixture of mainly triglycerides and some phospholipids. So from the cell membranes, you get phospholipids, but from the fat, the visceral fat and the abdominal fat of the fish, where it comes from, you get triglycerides. Mainly it's triglycerides, I think.
Yes,
but again,
from
it's
the adipose tissue mainly.
adipose tissue, yeah. Adipose and visceral, internal and external, and under the skin, yes. It's mainly triglycerides.
Well, I think we answered everything. Anyone have another question? We are here.
Questions or feedback, we are happy, and feel free to write us.
We have feedbacks of thank you very much and thank you again and thanks.
Okay, great. So Amy, if you're in line.
Oh, great job, and thank you so much, and thank you for all the attendees. You really generated a wonderful discussion. And as I mentioned,
there's another question. Alyssa just found another one.
Yes.
So
yes.
bear with us a minute. We want to answer the last question.
I think it's about the process. If somebody don't really get the process, we will answer it. You mean triglyceride in adipose tissue and gets converted into ethyl ester?
Yes, exactly. You take the triglycerides and the phospholipids and you decompose them to free fatty acids. You get rid of the glycerol and all the other components. You distill it at high temperature, very low pressure or vacuum. Every company has its trade secret, and I'm not a distiller, so this is just general knowledge. And after you get these components separately, you re-esterify them with glycerol or with ethanol. It's very simple. Actually, the triglyceride fish oil that you buy was first converted into ethyl ester, and then it was converted to a triglyceride, if I'm not mistaken about the process that I read.
Maybe we can share again our emails, and if somebody have another question, so you just can email us.
Update the email that goes out tomorrow that has the link to the recording, and I put both of your email addresses in it. So everybody should be, just look for that email that has the recording, and in there you can get both email addresses. Or you can also, if you need them today, you can get in touch with me and I'll be happy to get those to you as well.
Okay, so Alyssa, we had the last question, right?
Excellent presentation. Thank you very much.
Welcome.
Thank you, everyone. And thank you. And again, great job, attendees, for the great discussion. And thank you both for presenting with us. And we hope to have you back. Take care.
Great. Thank you, Amy.
Thank you.
2 years, right?